In this video, we will learn how to set up AWS CDK to deploy our AWS applications to both LocalStack and AWS. I will walk you through the CDK setup and configuration required to deploy a web API, a DynamoDB, an SQS, and a Lambda function triggered from the messages in SQS using CDK. We will deploy this both to LocalStack and AWS environment using the same CDK codebase. By the end, you will have a fully functioning app deployed to both LocalStack and to AWS Cloud and makes it seamless to deploy these applications. We will be using dotnet to author the CDK code. However, you can use any of the languages of your choice. Hello everyone, welcome back to this channel. My name is Rahul and I make videos on .NET, Cloud and DevOps. This video is sponsored by AWS and is part of my AWS CDK series. Now, if you're completely new to both LocalStack and CDK, I highly recommend checking out my previous videos on this topic. The links will be in the descriptions below. Now here, I use an existing application that I used in my LocalStack video, which I deployed to LocalStack using command line interface and also the GUI that LocalStack provides. However, that experience wasn't that great because you had to make a couple of deployment steps along the way as you make changes to your applications. However, deploying using the GUI and the CLI is not seamless and gets in the way in developing our code. So in this video, let's learn how to use CDK to set this up and unify all our deployment experience into one place. Now, I have gone and updated the existing ASP.NET Web API application that I had to also add in the CDK project. I do walk through the setup of a CDK project in my Getting Started with CDK video. So check that out if you're not sure how to set up the project. So if I navigate into the folder, you can see here we have the Weather Forecast API, a Weather Forecast.cdk project which contains the CDK contents and also a messages and service. Now the service is the Lambda function and the messages is a shared library. So if I navigate back to the root of this folder, you can see we have the cdk.json and a couple of other files. I have also updated the ASP.NET API to be hosted on Lambda function. So all I had to do was add a single line which is saying builder.services.add AWS Lambda hosting. And I'm hosting using HTTP API so that I can also expose it using function URLs. Now, if you want to learn more about hosting ASP.NET Core on AWS Lambda functions, check out my video linked here or in the descriptions below. Now, with that out of the way, let's focus on writing our CDK code. So let's move into our CDK project where we have the weather forecast stack and I don't have anything in it right now. So let's start authoring our resources inside here and see how we can set this up into LocalStack and also AWS environment. Now, to take a quick recap of the application, in the program.cs, we have a post endpoint which writes to DynamoDB, which publishes a message to SQS. So it takes in an Amazon SQS instance, all of which is registered in the dependency injection. Now, once the message is published, we have a weather forecast.service, which is nothing but a Lambda function that is triggered on the SQS event. So anytime a message comes in, we process that message and all we do is write it into the console. So let's see how to deploy this into CDK. So there's a couple of resources that we need. So let's list them out. So we need a DynamoDB instance. We need an SQS instance so that we can publish the message to. We have a Lambda function to process the messages. So Lambda function to process the SQS. And we also have the API to host. So we will also host that in the Lambda function. So we'll say Lambda function to host the API. Now for each of these instances, I'll copy and paste and walk you through the high-level structure. I don't want you to be sitting here to see me struggle typing through this CDK content. Now one pro tip I can give you is to create CDK is to use ChatGPT or any of the AI tools to come up with a base structure and then modify it as you require. That's exactly how I created a lot of these code as well. So let's get into it. So let's first set up the DynamoDB instance. So we have a weather forecast table, which is the table that we are writing to. So let's copy and paste. So we will be using the new table, which comes from the Amazon.cdk NuGet package. So let's make sure to import this. So we are setting up the table name, specifying the attributes on this. So in this case, we have two of them, which is city and date. So city is the partition key and the sort key is the date. We are also setting the billing mode to be pay per request. Next, let's set up our SQS code, which is even more simple because we just need to create a queue and we need to specify the queue name and also the visibility timeout if required. So we'll use the AWS CDK namespace again, and this sets up the SQS queue. Now, next we have to set up the Lambda function to process our SQS. So this again uses the new function which comes from the AWS CDK. So let's make sure to include that. And it sets up the function name, the runtime, which is .NET 8 in this case, the handler of this AWS function, which you can see from the AWS Lambda tools, and you can see the function handler inside this. So you can copy and paste that in here. We also need to specify the code that will be deployed. So I'm using code.fromAsset and making sure that we package the Lambda function into artifacts-service.zip file. I'll show you how that happens a moment later. We also set up the timeout to be 30 seconds. Now we can pass environment variables to the DynamoDB and the queue URL if that is required. However, this is not required in our case because all we are doing is processing the message as it receives in the Lambda function. But I'll leave it here just for reference. So let's make sure we have the dictionary type and let's move on. Now we need to make sure that this Lambda function has access to talk with SQS. And if required, we might also need to give it permissions to talk to DynamoDB. This is in case if you are pulling back the data from DynamoDB to process it further. So in that case, you can specify the permissions inside using weather forecast table, which is the DynamoDB table instance that we created in our first step, and calling the function grant read-write access and passing the weather Lambda function, which is the Lambda function that we intend to give access to. Similarly, we also need to wire up the SQS to be the trigger source for Lambda function. So for this, we can specify the weather Lambda function, which is the Lambda function in scope here, and the add event source and specify an SQS event source. Now in this case, the SQS is the weather data queue, which we defined earlier in this step. So now that our Lambda function processor is done, let's set up our web API. Now, to do that, this is similar for the Lambda function setup. So let's specify the Lambda function to host the weather API. So we have an API Lambda function, which is the weather forecast API. Specify the function name, the runtime, and the code. In this case, it's coming from artifacts/api.zip file. So both these Lambda functions are packaged into separate zip files that we can host inside our AWS. So let's specify the handler. In this case, since this is using ASP.NET Core hosted on a Lambda function, all I need to specify is the DLL name of that application. So in this case, that is weatherforecast.api, which is the same as the project name. Let's specify the memory size and again the timeout in this specific scenario. Now, since we need to expose this Lambda function on a URL, you can either go and set up an API gateway, or simpler enough, you can use Lambda function URLs. Now, if you're completely new to function URLs, I highly recommend checking out my video linked here, which will walk you through and give you an understanding on how to use function URLs. It's very similar to exposing your Lambda function as an HTTP API. Now, to add a function URL, all we need to specify is the API Lambda function, call the add function URL, and pass in the function URL options. In this case, I'm setting up the authentication to be none. You can also set up auth for your function URLs, and I have a separate video that covers that topic. Since we need this URL to access the API, let's also output this as part of the CloudFormation. So I'm adding a CFN output node, which writes the API function URL and writes that value for this function URL. You'll see this in the console once we run the CDK deploy. Now this Lambda function again needs to talk to SQS and the DynamoDB because it's sending up messages to it. So let's add weather forecast table.grant read-write access and give it access for this Lambda function as well. Similarly, for the weather data queue, we need to send messages. So let's give that access too. Now, if I navigate into my ASP.NET API, the last time we had to set up on LocalStack, we set up a couple of settings. So we did override the app settings.development.json to set up the AWS information. In this case, we are setting up the region and the service URL, which will be overridden in each of the client SDKs. We also set up the authentication region to be AP Southeast. Now, this is the region where I want the resources to be deployed. You can choose whatever region you want. Now, the service URL points to the service stack URL. So all of service stack services are exposed on HTTP localhost 4566 by default. Now, if I navigate into my local stack, desktop, and if I start my instance, we will have an instance on 4566. So you can see I already have an instance created from the previous video. So this is listening on 4566. So let's make sure to start this container. Once LocalStack is up and running, to establish the connection, let's navigate into the resources and which prompts you to log in to this specific account. So we can copy this code and paste it inside here to establish the connection between our account and the LocalStack running on my local machine. I walked you through this in the previous video. Now, when hosting the API inside the local stack, it cannot use localhost to access the other services. Now, since this is running inside the Docker container to access the other instances within the Docker container, we can use host.docker.internal instead of localhost. However, we need a way to set that up. So let's create a new app settings file for LocalStack. So instead of development, we will be renaming this as LocalStack. So I will be specifying localstack.json. Now, all we need to change in that is instead of localhost, we will be using host.docker.internal to reference the other instances. Now, since it is on the same port, we are okay to use the same port. Now, once that is set up, when we use the CDK deployment, we'll need to make sure that our ASP.NET API application runs in that specific configuration as well. Now, we've seen in a previous configuration video and also in my environments video that this is purely taken by the environment name. So if your environment name is development, it will also load appsettings.development.json. So we'll need to set up an environment such that it is local stack so that it will pick up this specific configuration file as well, in addition to the app settings.json. Check out my configuration videos and also my environment videos of ASP.NET to understand this better. So once that is set up, let's navigate back to our weather forecast CDK so that we can set up our Lambda function to have this ASP.NET environment. So for this, we can use CDK context to get this data in. So in here, I'm creating a new environment variables dictionary, and I'm checking if the ASP.NET Core _ environment property is set on the context when the CDK is being invoked. We will see how to pass this a while later while we deploy this code. So if the ASP.NET Core environment exists, I'm going to add that as an environment variable inside this specific Lambda function. So when the Lambda function is going to run, we are overriding the ASP.NET Core environment, which means it will choose that specific environment for this Lambda function or the ASP.NET API to be running. So let's make sure to also assign this environment variables to this Lambda function. So we can specify the environment and specify environment variables. So let's make sure to copy this code that we need to pass in when we run the CDK. Now, if you know a better way to achieve this, let me know in the comments below. Let's see how we can deploy this. So let's navigate into my console where I'm at the root of this project, weather forecast servers. So if I open that in Visual Studio Code, in here, we have the build.ps1, which has the build code to generate the zip files. This is nothing but using the .NET Lambda package function to specify the project location, the configuration that it needs to use, the framework, and also the output package. You can see here it's packaging it to artifacts.api.zip and also artifacts/service.zip. These are the two files that our CDK code is referencing. So we need to make sure that these packages exist by running this build.ps1. You can also copy and paste these commands independently, but I've just made it easier so that we have it in one file. So anytime we want to build this project, we can simply run build.ps1. You can also tie this into the build from Visual Studio or JetBrains Rider. Let me know if you want to learn more on how to do that, and I'll show you that in a separate video. So once we have this, let's go back to our console and run the build.ps1 to make sure this is running successfully. So this is going to run the AWS Lambda package command and generate the artifacts that we require to deploy to our AWS resources and also LocalStack. So the build is complete. So if I navigate into this folder and artifacts, you can see those two files, api.zip and service.zip. Both of these are Lambda functions. Now, in the local stack video, we installed the AWS local CLI to make it easier to work with AWS resources on the local stack. Similarly, with CDK, there is a CDK local CLI command that you can install. I'll put a link to this in the description. So this again is coming from local stack. This provides a wrapper script around the CDK commands. So we can use npm install and specify AWS CDK local and also AWS CDK, which is around which you are wrapping these functions around. So I have this already installed. So if I run CDK local, I can get the details of that specific wrapper function. Now we will be using CDK local to deploy this into our local stack. So if I come back, I have the local stack all up and running. So let's make sure to first bootstrap the local stack instance. This is very similar to how we did it in our CDK video earlier to bootstrap our AWS account. So let's specify CDK local bootstrap, which is going to bootstrap our account and make sure that it can work with CDK. All this is going to do is set up some S3 buckets and resources that CDK will be using to deploy contents to AWS, or in this case, local stack. Now, once that is done, we can deploy our CDK code. So let's specify again CDK local and let's specify the deploy command. We also need to specify the context for our ASP.NET Core environment. So let's make sure to specify that variable and let's specify the value. In this case, we need to specify it as local stack, so it will pick up the app settings.json file. This command is going to trigger our CDK stack and deploy that into local stack. So you can see here it's prompting for confirmation. So it's making DynamoDB, SQS, and all these ARNs that's going to be changed. So let's say yes and continue with the deployment. So this is right now creating the CloudFormation change set and deploying the resources into local stack. The deployment is complete, and you can also see here that we have the weather forecast API function URL. Now this is the URL where our API is currently listening to. Now if I navigate back into local stack and let's navigate into this, go to resources and look at Lambda, and here we can see two Lambda functions. So we have the weather data processor and also the weather forecast API. Now, if I navigate back and go into DynamoDB, we can see our DynamoDB table as well, which is weather forecast data. Now, we also have an SQS that is getting written. So if you navigate into SQS, you can see a new queue, which is weather data queue. So let's navigate into one of these Lambda functions, which is the last one that processes this message. And let's look at this logs. Now, we'll use this URL to post a message. So let's copy this URL and send a post message. So I'll use Postman for this to sending a message into this. So let's open up Postman. Now I already have the URL set up here. So let's change the URL. So let's make sure this is the right URL that we just created. And we also have the /weather forecast, which is where our API is listening. Now this is a post request. And I also have the body, which is going to be Brisbane, and it has the summary as cool. So let's send this message to our API endpoint on local stack. Now, which is going to pick that up and run this. So you can see our Lambda function has got triggered and it is saying processed message for city Brisbane. Now, this is the Lambda function that processes it. So if you remember from our code, we send the message to DynamoDB and publish a message into SNS. And that is getting picked up by a Lambda function and processed, which is what is writing that. So you can see update process message for city is written in our Lambda function. So the message has gone through all the resources and successfully processed. Now, if I navigate back in here, we can also navigate to our DynamoDB table and inside the weather forecast data and go to items, and you can see the Brisbane 10 and cool, which is the exact same item that we sent. So we've successfully deployed and run our application in local stack. Now let's see how we can deploy this to our AWS account. So all we need to do in this case is instead of using CDK local, we'll be using CDK and specifying the deploy command. Now in this case, we don't need to set up the ASP.NET Core context in the environment because we don't need that specific configurations to be set up. It will be running in my AWS account and will be using the AWS account resources by default. So let's simply run that. And this is going to deploy this into my AWS account. It's again prompting for permissions to create all these. So let's specify yes. and this is going to create the resources. So if I switch over to my AWS account in here and let's navigate to CloudFormation, you can see this new stack in progress for creation. So let's navigate into that and we can see each of the resources getting created. So we have the weather forecast data, which is the DynamoDB table, the queue, the processor, and the API. So all of these resources are right now getting created. The CDK deployment is complete, and again we have the function URL in here. So let's navigate into that URL, and we can also navigate to /swagger/index.html if we want to use the Swagger UI. Now in this case, the Swagger UI is loaded from our ASP.NET API, which is running on the Lambda function. So now if I navigate back into CloudFormation, you can see all these resources being created in here. So let's navigate into the weather forecast data, which is the DynamoDB table, and let's also navigate into the weather data processor and make sure that this is processing the message by looking at the CloudWatch logs. So let's navigate into monitor and view CloudWatch logs. Now right now we don't have any table items inside this table, so let's make sure to create one by invoking this API endpoint. So let's specify Brisbane, let's specify 27 because it is very hot here right now, and let's specify hot. So this is going to write to our DynamoDB and publish a message, and that's going to get processed. So let's navigate back into DynamoDB, refresh this, and we have the item inside that. Let's also navigate to CloudWatch and refresh this so that it picks up the new CloudWatch log groups, and we can see the message inside that. So here we have the log stream, and we have the message update process message for Brisbane and the temperature that we just sent. So we have successfully deployed our application using a single CDK code base, both into AWS LocalStack and also our AWS account. Now, in a future video, I'll show you how to set up the AWS deploy to AWS account using GitHub Actions. If you want to be notified when that video comes out, make sure to hit the subscribe button. If you like this video and found this useful, make sure to hit the like button. Thank you and see you soon in the next video.